Let's say we wanted to approximate the square root of 26. Well, we really don't know what the square root of 26 is, but we can approximate it by looking at what it's close to. It's close to the square root of 25, which of course is 5. So in the old days, back in Algebra 1, if your teacher would say, okay, approximate the square root of 26, you could say it's about 5. We wouldn't, because it's closer to 5, then it would be closer to 6. So we're going to talk today about how can we be more accurate. And that's what we want to talk about today. Can we be more accurate in order to find the square root of 26? So let's start by taking a look at something we call the tangent line again. And one of its main applications is to approximate values. We want to use the tangent line to approximate the cube root of 127. So to do this, we're going to let our function equal the cube root of x, and then choose a perfect cube very close to 127. And build your tangent line at that x value. So we are going to build our tangent line. So if I let f of x, I'm going to build my tangent line. If we know f of x is x to the 1/3, to do our tangent line, remember, we are going to need a point and a slope. Well, if I try to plug in 127 for the cube root, I really don't know what that is. So I'm going to pick a perfect cube close to 127, 125. Well, if I plug in 125, the cube root of 125 is just 5. So our point, 125, 5. Next, I need to find the slope. So of course I have to take the derivative. So our derivative, f prime of x, becomes, what's that, 1 over 3. This becomes x to the 2/3. We can go through these a little bit quickly now. And now, to get my slope, I'm going to plug in the 125 again. We get 1 over 3 times 125 to the 2/3. We don't like to leave it this way. So the cube root of 125 is 5. 5 squared is 25 times 3 is 1 over 75. So my tangent line would be y minus 5 equals 1 over 75 times x minus 125. There's my tangent line. Now I can approximate. So now we're going to let x equal 127. Whoops, that's we're looking at 127 there. And we would get y minus 5 equals 1 over 75 times 127 minus 125, or y would equal, what's that, 2 over 75 plus 5, or 5 and 2 over 75. Now as a decimal, that is about 5.02667. Next, we want to determine if this approximation is an overestimate or an underestimate. That's not too bad. Anytime we talk about overestimate or underestimate, you might remember from the other parts, we are talking concavity. Overestimates and underestimates, we look at concavity. Well, I know what this function looks like. F of x equals x to the 1/3. Kind of looks like this. And at 125, notice it's concave down. So which means any tangent line on it has to be above. So we can say f of x is concave down at x equals 125. Therefore, our estimate is an overestimate. And there we have it. Then they want me to find the error of the approximation. Remember, to get the error, we have to get the actual value. So we're going to have to use our calculator for that one, the cube root of 127. And I'm going to go ahead and use my calculator for that. So let's see here. Go to my home screen, homies. And I'm going to take 127 to the 1/3. Oops, write that as a decimal. Enter. And I get 5.02653. I'm going to go up pretty far here because look, they look pretty close together. So to get my error, remember error is a distance, so error always has to be positive. I take my actual value minus my approximate value from above, 5.02667, and I subtract. If I minus that from 5.02667, we get an error. Oh my gosh, look at that. That's 1.44 times 10 to the negative 4, or 0.00014. Now notice it is negative, but we are looking for the absolute value, so it's going to be positive. So that's how far off we are from the actual answer. All right, so I hope you enjoyed this application. Take a look at it again. This is very big for us on the AP. You will see this in the future. Bye-bye.